Hello, and welcome to part 2 of the Data Notebook. I am Peace Awesome Williamson, and I'm excited to share the Float framework for engaging in research. Data have become increasingly important to the field, and it is crucial to develop skills for working with data in a meaningful way. Actions as simple as counting things can lead to great discoveries. Some examples of this are listed in the CDC's 10 greatest public health achievements of the 20th century, which include infectious disease prevention to food and drinking water safety. We know that your zip code plays a bigger role in your health than your genetic code, and you can see some evidence of that on this chart, showing that life expectancy in Dallas, Texas can vary as much as 23 years just based on where one lives, with the highest and lowest zip codes being almost right next to one another. And this is not unique or exclusive to North Texas. This chart and map come from the Dallas County Community Health Needs Assessment in 2019, and similar data for metropolitan areas across the U.S. are available from the Robert Wood Johnson Foundation. So, how can we use data toward making discoveries? We need to first understand the topic we're exploring. This could be an author, a community, a political landscape. What are the areas of conversation and research around this topic? And what are new avenues to explore? Second, we also need to consider the experience, the knowledge, and the expertise of the personnel we have available to us. Typically, that is the resources and support staff that are available in your school or university. If you are a student, you may have friends you can collaborate with, colleagues, and professors. However, I'd like you to think about this for this program as well. What are your strengths and experiences in working with data? Write it down. Also, jot down what tools you know and analyses you can perform. Even something like comparing two sums to see which is greater. A lot of times, people interested in research expect that they aren't doing research with a capital R unless they are running complicated analyses, using machine learning, or other very technical and advanced methods. However, simply exploring trends, mapping data, or seeing differences between groups are very much needed research. Summary tables can be extremely enlightening. John Snow's map of a cholera outbreak in 19th century London is still highly lauded to this day, but Snow used public data to create a bar chart with the locations of the bars on a map to show where the deaths were occurring. You can see the map here in the 3D form. The third step for preparation is making use of the best available research evidence in order to make informed decisions. Have others perform similar research, let's say on a different artist or time period? How can you review what they did and start from there as a guide, rather than building from scratch? What are things that are known about your topic that can help you avoid pitfalls? Having the background in the topic of study, whether that is humanities, public health, or something else, will make you a much more reliable researcher. So now let's dive into how the float is practiced. There are other frameworks, but I will discuss the data research framework my colleague, Dr. Kenton Ramsey, and I developed. You'll also see how these steps are applied as you progress through part 2 of the data notebook. The float method is a 5-step process that facilitates your ability to outline your project by conceiving of a research question, explaining how you locate, organize, and analyze a given data source, and finally, transforming your findings into some type of dissemination, such as a visualization or report. The float method is a process by which data analysis can occur. Data analysis is the process of exploring data to bring about insight or particular findings. Data analysis can be part of a study, which involves the development of research design, data collection, and interpretation. Data analysis can also stand alone, being performed on data that are already collected. Ultimately, the float method offers a systematic way for you to conceive of and execute a data-driven project. The float process involves cycling through activities, all of which can take drastically different amounts of time, effort, and focus. Even the steps themselves can differ greatly across projects. The first step is formulate, or finding out and understanding what's actually happening and assessing the need for resources. At this stage of understanding, you can form a question of interest. The next step, or locate, involves quantifying the issue and identifying sources of existing data related to the issue or collecting the data yourself. Even collecting data such as page clicks or how many times a word is used in a text can be your data. At this point, the locate stage, you should begin to be able to articulate the problem in an effort to build support for the issue. This could be in seeking help from an analyst or an advisor. Of course, you should inform your work by searching the scientific literature to determine what has or hasn't worked in the past, information or insights already obtained, and other ways that past research has led up to your study. Challenge yourself to think about what the term data really means. Data are more than spreadsheets you can download. Think about other ways to quantify concepts of interest. Review the Big 7 research project where Dr. Ramsey transcribes tables of contents from anthologies to determine which Black short story writers were the most prolifically anthologized. Next up comes organize. What are the options and resources available to engage in any level of assessment? Is this a structured table in Excel, a regression in SPSS, or a visualization in Tableau? Once you are aware of the software, expertise, and supporting resources available to you, you can begin to adapt your data in preparation for analysis, which can include restructuring, grouping variables, and making sure the data are clean. Afterwards, you will analyze your data and reach findings, possibly preliminary. Again, these don't need to be the most complicated analyses available. Oftentimes, that behavior can lead to false conclusions, and big data can lead to finding any outcome due to its size. For an example research study that came from some data work, review the article for JMIR Public Health and Surveillance by me and my colleagues. I encourage you to look at ways you can thoroughly document the steps taken. You can start practicing the skill of documentation by a research protocol, which is a plan for your study. This will allow you to move to the final stage, tell. In any field, there are always stakeholders, whether they are from the community you're studying, funders and financial backers, other researchers in your area, and many other groups. Therefore, being able to effectively share your results with a broader community is crucial for it to be understandable and actionable. If it's possible for you, try to publish or otherwise disseminate your findings in an open, effective way, because we continue to bolster the scientific research by sharing with others what we've learned, our successes, and what barriers we encountered and whether and how we overcame them. This becomes a circular engagement because if you recall earlier, I mentioned how helpful it is to review what others have done to inform your own work. This is the same process, but now relayed for the next researcher. Float isn't always a linear process, but the work continues on an ongoing basis, and some answers can lead to even more questions. We are excited to share part 2 with you and introduce you to the methods of working with data using the Float framework, and we hope you enjoy this section of the Data Notebook.